Binary math, the foundation of IP addressing. In order to understand IP addressing, we have to understand binary math. So in this section, we'll first look at what octets are. Then we'll look at taking binary numbers and converting them to decimal numbers. We'll look at how we take a specific number of bits and determine the number of addresses that those bits could provide. And then we'll talk about binary counting. Bits and bytes. First, let's talk about a bit. Now, a bit is a single digit that can take on the value of 0 or 1. A byte is a combination of 8 bits, and it can be any combination of zeros and ones. Now, we're going to see that in IP addressing, we call a byte, 8 bits, an octet. One important skill we'll need in IP addressing is to be able to take an octet of binary numbers, 8 bits, and convert them to their unique decimal equivalent or decimal number. We do this by using the decimal conversion chart you see highlighted in red on the slide. Each location or each bit has a unique decimal equivalent associated with it. When converting a binary octet to a decimal number, we take the binary octet and compare it against the decimal conversion chart. Now, the decimal conversion chart associates a decimal value with each bit location of the octet. If there's a 0 in the octet, we don't add the associated decimal value to the total. If there's a 1, we do. Now, in our example here, we have an octet 00101110. We compare that to the decimal conversion chart, and we see that there's a 0 in the 128 location. So we do not add 128 to the total. A 0 in the 64 location, no 64 added to the total. A 1 in the 32 location, so we add the decimal value of 32 to the total. No 16, there is an 8, we add 8. There is a 1 in the 4 position, there is a 1 in the 2 position, and there's a 0 in the 1 position. So we total up all the numbers from the decimal conversion, the 32, the 8, the 4, the 2, and we get a value of 46. So this means that if, for instance, we type in the address 46 into a computer, the computer would convert it to the binary number 00101110.
This slide has 4 different problems to test your abilities to convert binary numbers to decimal numbers. Now, this slide will pause for 30 seconds before going to the next slide that has the answers. Now, you can hit the pause button at this point or print out these problems as part of the practice set.
Another important skill we'll need in IP addressing is to be able to determine the number of addresses or number of values we would get from a specific number of bits. Now, if we had 1 bit, that bit could take on the value of 0 or 1. That would be 2 addresses. Now, if we had 2 bits, there's 4 possible addresses, or 4 different values, 00, 01, 10, 11. If we had 3 bits, 3 bits could take on 8 different values. That would give us 8 addresses, 00, 0, 001, and on and on. With 4 bits, we get 16 addresses. With 5 bits, 32 addresses. 6 bits, 64 addresses. 7 bits, 128 addresses. And with 8 bits, a full octet, we get a possibility of 256 addresses. It's important to realize that every time we add a bit, the number of possible addresses double. For instance, if we had 4 bits, we would get 16 possible addresses. If we add another bit and go to 5 bits, we get to 32 possible addresses. And if we went to 6 bits, again, the number of addresses would double to 64. Likewise, every time you lose a bit, the number of addresses would halve. So if you have 8 bits, now again, 8 bits gives us 256 addresses. If we lose a bit and go to 7 bits, the number of addresses halves, or goes to 128 addresses. For the mathematical types, the number of addresses is 2 to the exponent n, where n is the number of bits available. So 2 to the 8th would be 256 possible addresses.
Now, another important skill we'll need to have is to be able to count with binary numbers. Here we're taking a look at a binary octet, and the first binary number would be all zeros. And when we convert that to a decimal number, we'll see that that is, of course, a 0. The next binary number is 7 zeros and a 1. When we take our decimal conversion chart and convert that to a decimal number, that's 1. The third binary number would be 00000010, converted to a decimal number of 2, and so on and so on. Now, when we take a look at the first binary number in an octet, it's all zeros, and that converts to the decimal number 0. The last binary number is all ones, and that converts to a decimal number of 255. Now, remember when we take a look at an octet of binary numbers, it provides us with 256 possible addresses, the first address being the decimal number 0, and the last address being the decimal number 255.